Glad to see you all. Like 7 years ago, I was working for an e-commerce company where we were doing a library for developers, actually a set of libraries for like 500 plus developers who were doing microservices. The company was transferring from PHP to Java, and we based that on Spring Boot and Spring ecosystem. And we were all happy with integrated tracing into our libraries and made them available to developers. And everyone was happy because they could see the logs with correlation identifiers in the form of trace IDs. But then Spring came with this idea of WebFlux and introduced reactive programming. And then everything broke with the correlated logs. Have you been in that situation? I sure have. And I've been trying to solve that. And other people have. They joined our team. They looked at ways people are solving that issue. And there's this library, Spring Cloud Sleuth. Has anyone used it? So Sleuth has a long history. It's been working with Reactive, once better, sometimes worse. The performance wasn't that great. Then they made changes, but introduced some bugs. And the latest edition of Spring 6 and Spring Boot 3, no longer supports Sleuth, but Micrometer. So in order to make ThreadLocal state, which helps to correlate logs, work with Reactor, we did some really exciting things that I want to show you today. So before I actually jump in, take a note of the legal disclaimer, take a picture if you want, and let's kick off. So if you're not familiar with MDC, that's like a map diagnostic context, where it is essentially a map that is backed by ThreadLocal storage. And the common pattern for doing logging with correlated identifiers is that you put something in the map. In here, as you can see, there's a CID field for which we store some kind of string. Here, it's a correlation ID variable. And the next thing we do is someplace else within our application, we just call log dot and whatever we want to log. And we assume that the correlation identifier related to that transaction is happening and is being recorded without the need to pass it along every time. Well, once we have a Spring application that we're going to use Spring MVC for simplicity in the beginning, we might have a common pattern where we have a filter. For every request, it is going to extract that correlation identification data. In this case, I'm using the name provided by query parameters. And sorry, let me go back. And I put it in the MDC just like I've shown before. And then what happens is the chain.toFilter is going to execute the controller. And whatever we have in the controller can call log.info, debug, and so on. And we should see that correlation identifier associated with that log statement, as long as we have the logging pattern aware of that. So here, what I'm using is the logging pattern level from Spring, and I attach that CID to every log that I perform. Then the example controller would look like this, where essentially when the hello endpoint is called and the log statement is called, I should see that information printed somewhere in the logs or in the logging system that I'm using. And at this point, I just want to make sure that everyone understands what correlated logging means. Is everyone aware of that? Who's heard of correlated logs before? Cool. So for those of you who haven't, when you have a lot of transactions happening in the system and they are happening concurrently, then you would like to know which situation in the application that is being logged belongs to that transaction. And if those transactions are happening at the same time, those logs can be mixed, so you wouldn't know which one is causing a problem, for instance. So that's why you want to have some kind of correlation between them. And let's have a look. If we make a request to that endpoint, the hello endpoint, a particular log would look like this. where, as you can see, the CID that I provided in my curl parameters is present in the logs. That's what we want. Well, that sounds great, as long as we don't use reactive, right? So every user on the web might say, we want the same for reactive, but it just doesn't work. Well, let's see how it doesn't work. This endpoint here, it essentially, the first thing it does is it logs that the endpoint has been called. And the next thing we are doing is we are using WebClient, which has a reactive API, and it does a jump to the event loop, and then continues processing where we will get the response in the do-on-next operator, and we are trying to log that. Let's see what happens if we actually perform a curl request to that endpoint. Well, the first one is great. We see the correlation identifier, but the second one is unfortunately absent. So for that kind of problem, we are very happy to start working with the context propagation library in the latest editions of Reactor. The context propagation library was a common effort of the Micrometer team and the Spring team and Reactor as well, which allows for mapping ThreadLocal state between map-like structures. For instance, GraphQL context, Netty attributes, but in particular, as a subject of this presentation, the Reactor context. And it allows to transfer that data across thread boundaries. So in order to use this library, you can import it in your Gradle or Maven setup as context propagation library. And the good news is that Reactor Core natively integrates with that library whenever it is present on the class path. So once you have it, and there is some kind of mapping inside the Reactor context that you have registered, it will transparently make that available in ThreadLocals. And let's have a look what you can do with Reactor to interact with that kind of magic. So there's operators such as context write and context capture, which allow you to store data in the Reactor context and make that data available for ThreadLocal state. And if you want to access it, there's two dedicated operators. One is tap and handle. And within the lambdas that you provide, or the implementations that you provide to these operators, you will get that ThreadLocal state automatically restored for you. But I have good news. If you want to have that available in any operator, then you can use automatic mode, which we introduced in 3.5.3 version, but that essentially gets improved over time. So the latest version is 3.5.9, as far as I remember, and it's like the best experience so far. So the good news is that you can access ThreadLocal state in any operator across thread boundaries. And we made an improvement recently where for blocking operations, such as the block operator, block last in case of Flux, collect list, it automatically captures the ThreadLocal state. So imagine where you are using the MDC, you put some data there, and you call block, it will be automatically captured into the Reactor context. So I think that's pretty neat because it improves the lives of developers who are working with Spring MVC applications and use WebClient. So let's see that in action. So what you can see here is the help file of the project generated from start.spring.io. And my controller essentially is going to serve, to fetch that file, which is served by the web server from Java 19+. And what's happening here is what I've shown you before. So that's the endpoint that's using the WebClient API to retrieve that help file, and it does the logging. And let me quickly show you, when I'm going to run the application, that the problematic situation occurs that we've discussed. So let me make a curl and see what happens. And as you can see, the first log has the correlation identifier, the second log, unfortunately, lost it. So, well, I told you we can do something about it, so let's try to actually do it. I'm going to go to Gradle, and I'm going to add the context propagation dependency. I'm going to refresh the project. The next bit that is important here is to use the context propagation library for the CID identifier. All right, so the way it works is there's a registry where I register a ThreadLocal accessor. It is associated with the key of CID. And what it does is it essentially calls the MDC API to get the correlation identifier from the map diagnostic context. The next thing is storing it, and once it's done, it's removing it. It's as simple as that. There can be more complex scenarios, but this is the basic one I wanted to show you. And that wouldn't be all working if we didn't use the hook from Reactor core to enable the automatic propagation mode, which makes that state available in any operator. So let's try if this helps. I'm going to make the curl request again. Go to the logs. All right, great. So it actually works, and it might be even more elaborate. So let me try to change this endpoint. As you know, Spring MVC supports reactive endpoints. So let me just make this endpoint a reactive one by changing the signature of the method to return a reactive type, in this case mono. And I need to get rid of the block operation at the end, which essentially converts this to a reactive endpoint, right? And if I rerun the application, and notice I'm not doing any changes to the code base aside from the mechanics around my setup. Did I rerun it? Hopefully I did. Okay. And as you can see, it still is maintained. Let's do something more. Let's convert this Spring MVC application to a WebFlux application. We don't need to change any code. We just need to change the dependency that is going to be configuring the server that we are running on. So in order to do that, the only thing I need to do is I need to remove the Spring Boot Starter Web dependency and refresh Gradle. Before we do that, I can show you that here a dispatch servlet is starting, right? So this is a characteristic of the MVC approach. If I rerun this now with the removed dependency, I will not see that anymore. I will see that Netty has started because it's the, let me go back and change a few things. So first of all, in WebFlux, we cannot use the filter anymore, right? So let me remove that filter and convert this code to a web filter, which is the construct used with WebFlux controllers. And here, it's more or less the same. I am extracting the name of the query parameters, and I am also calling the chain.filter, but this time, what it returns is a reactive type. So it's actually creating the pipeline of reactive operations. And in here, I'm no longer writing to the map diagnostic context. I directly use the context write operator on the reactive type, such as flux or mono, and I insert the CID key and the value that I want to store there. So I'm not interacting with ThreadLocal state anymore. The source of truth for the reactive pipeline is the context. And Reactor, together with the context propagation library, is going to use the Reactor context to restore ThreadLocal state for us. So I guess that's it. The only thing missing is the import removal. Let me try to run it again. And make a curl. All right? So as we can see, the thread is from HTTP NIO that signifies the event loop. and the correlation identifier is still preserved. And like I said, we are using a native web server here. Cool, so that concludes the part where you did all the necessary work of configuring all of that. But isn't this boilerplate? Do you want to do this? Well, if you have a custom configuration, like you're dealing with custom correlation identifiers, like I did when I couldn't use sleuth, then you might need to do this, but this is a lot of help, I think. But in case of a regular Spring application with Spring Boot and Actuator, you don't actually need to do anything because there's this amazing effort by the Micrometer team, which is essentially a set of observability tools bound together in one library that we are integrating in Spring, in Reactor, and it works well together. Starting from Spring Framework 6 and Spring Boot 3. You can attend the presentation by Jonathan and Tommy on Wednesday. It's a great talk. They are going to talk more than I am about metrics, about tracing, so all the other things of observability that you want to focus on. But here we're just describing like the raw details, like the very granular part, which is super important if you want to dig deeper into what's happening in your app. So in order to take advantage of the automatic correlation happening together with tracing by Micrometer, we just need to import one of these libraries, Micrometer Tracing Bridge OTel, which works with OpenTelemetry or Brave. And let me show you. Here, what I'm actually going to do is remove all the code that I have added because it's not going to be needed anymore. So I remove the context registry, so the raw interaction with the library. I am going to remove the filter. Right. What I'm going to leave is the automatic context propagation hook, which essentially does the magic of making the ThreadLocal state available in any operator, just to repeat that. And I'm not changing any logic in my controller. No business logic needs to be affected. What needs to change is the logging pattern level, because I no longer will be using the CID that I added on my own and added that custom configuration. What I will be using is something that is present provided by the integration of Micrometer tracing, and that's a trace ID and span ID fields. And the last thing is changing the context propagation library to include the bridge, right? That's all. Let me refresh the project. And rerun it. Okay, let me make a request. And as you can see, we have the trace ID as the first field here in the log and the span ID from the tracing library. And it's also present after the response gets back from the remote call. So that's that. So just to recap, what we worked on recently is, well, we think we managed to get a proper reactive log correlation mechanism into the project that you can work with in your custom scenarios. You can take advantage of it when you migrate to Spring Boot 3 and you have the actuator and you were using sleuth, but the migration could have been difficult because you would need to use the tap and handle operator. With the automatic mode, you can leave your code base and just take advantage of the shiny new things. You can use it in Spring MVC with a blocking call. You can use a reactive code base with Spring MVC. And you can also go full reactive with WebFlux, and still the ThreadLocal state for logging purposes or any other purpose is going to get propagated for you. And of course, I highly recommend integrating that with Micrometer because it's really cool. So if you'd like to find out more, we have a Twitter handle, Project Reactor, where we publish when we release new stuff. We have the website, projectreactor.io. And if you'd like to dig deeper, experiment with the code, gain more trust that it's working, add new operators, go ahead and grab the repository that I've developed. It's down below. And there's even more examples with descriptions, like what you need to do, what you need to alter to make it work. So there's like 2 branches, main and solutions. So you can try experimenting with that. And please take a survey so that I know if you enjoyed it, what your thoughts were. And I think we have a lot of time for questions, so I'm happy to answer. Sorry, are we getting a mic for the questions, or should I repeat them? Do we have the standing mic? Sorry.
Right here in the center.
Aha, oh, sorry. Can you go closer? Thanks.
Request context to make it automatically propagating Reactor context as well.
So the question is for a security context. That's a question to the Spring Security team, I believe. But to the best of my knowledge, they are working with the observation and they are propagating the context. But you should ask that team and reach out to them to get more details, because I'm not working on that and not involved in the Spring Security stuff. The context registry primitive where you register the ThreadLocal accessor. Yeah, there's more, like this is just the basic API where you provide like a getter, a setter, and something to remove. You can actually provide a full-blown implementation where you can do whatever sort of thing that you want to interact with any kind of ThreadLocal state that you would like to represent as something that can be put inside a map. And that map can become, in case of GraphQL, they also have attributes that they use for ThreadLocal propagation. Not sure if that answers your question, or do you have a more elaborate scenario? If you want to come and talk later in private, we can do that as well. Sure. Any other questions? Well, thank you very much. Thanks for coming.